So this is section 6.5 in Algebra 2, and we're just going to dive right in. This is the last section of this unit. So you may recall that earlier in this chapter, we learned how to solve the inequalities. An example might be absolute value of 2x minus 1 is less than or equal to 10, something like that. And what we said to do was you have to write two equations or two inequalities, and then look at your two answers. So now we're going to talk about what does that mean graphically. All right, so first of all, we're going to graph the equation, this absolute value equation, using the parent function idea. So it's going to be the absolute value graph that's been moved 2 units to the right and 1 unit down. So that's going to be the vertex. And remember, absolute value is kind of that V-shaped graph that has a slope of 1, and it's going to be pretty important to keep these somewhat accurate when you're solving these inequalities, because we're going to need to look and see where the graphs intersect. Okay, so look over at the next, or over here to the right. It says we're going to solve this inequality, and I want you to notice that the left side is exactly what we graphed up here in that absolute value. But the right side, it says we want that whole absolute value to be less than 1. So look at letter A. The next step is we're going to draw a horizontal line at y equals 1. And the reason 1 is because that's what's on the right side of this equation. So we're going to draw a horizontal line right here at y equals 1 all the way across. Okay, and letter B says what part of the absolute value graph is below the horizontal line. And the reason we're looking at below is because it says right here in the equation, I want the blue, the absolute value, to be less than, that means below, the red, which is the line at y equals 1. Well, the part of the blue, the part of the absolute value that's below would be from this point, all of this down here, and all of this down here is actually below the red graph. And so we write, since it's not just 1 point, since it's a whole interval, we would say everything from x equals 0 all the way over to x equals 4. Remember, when we write interval notation, we use x values. And the reason I'm using parentheses, again, is because up here that less than did not have an equal to sign with it, right? It was just a less than. Okay, so we're solving these by looking at the graphs. So look at number 2. Let's start by graphing. This time it's not an absolute value, but it's a parabola. Okay, so if I graph that parabola, it's 3 units to the left, 4 units up. So there's the vertex. Remember that 2 out in front means that first point is kind of like a slope of 2. So that's going to be the parabola. Okay, that's I need to make a change here. I forgot that I had written this incorrectly. Over here, it should be x plus 3 and then plus 4, because I want this to be the same one that we just graphed up here. All right, and so now notice on the other side, there's a 5. And so that means, letter A, we're going to draw a horizontal line at y equals 5. So right in here, all the way across. And then letter B, what part of the parabola is above? Well, the reason we're looking at above is because when you read this, it says we want the parabola, which is in blue, to be greater than, that means above, the 5, which is in red. So the part that's above, there's actually 2 parts. It would be this side of the parabola is above, and this side of the parabola is above. So since there's 2 parts, we have to write 2 intervals. And since this parabola keeps moving to the left, even though we don't see it, I'm going to say from negative infinity up to, and then this x value right here is negative 4. And because of that equal to up there, I'm going to use a bracket on the negative 4. Remember, we always use parentheses on infinities. And then the other piece is from x equals negative 2, and again with a bracket, all the way out to infinity. And the reason we're saying infinity is not because it goes up, but because as it goes up, it keeps moving to the right, if I were to exaggerate it. Okay, so look at number 3. So this time up at the top, it says to graph this parent function, notice it's a cubic, So we want 3 units to the right, 2 units down. And if it's a cubic, remember we kind of have that point on either side, and then it kind of does this kind of thing. Okay, so I just graphed this cubic equation. Notice on the other side is a 3. So letter A, draw a horizontal line at y equals 3. So we draw our horizontal line at y equals 3 all the way across. And then letter B says, what part of the graph is, well, do I want above or below? Notice there's a less than, so I want below. Okay, and so what part of the blue is below the red? Well, wouldn't that be all of this? So because the intervals are x values, again, if you were to continue this out, it's going to gradually keep moving to the left. So I'm going to say negative infinity all the way up to x equals 5. And because of the equal to up there, we're going to use a bracket. Okay, so the next two, completely on us. There's nothing leading us through. We just have to remember what we do. So we graph the left and the right side separately. So the left side is the square root graph, 5 units to the left, 3 units down. And remember that 4 out in front, that 4 out in front is kind of like a slope. So if I'm drawing the square root graph, it's something like that. And then the right side, we have a 1. So we draw a horizontal line at 1. Horizontal line at 1 all the way across. And then because of the greater than, right, I want the square root, which is blue, to be greater than the 1, which is red. And so above, so the part of the blue graph that's above would be all of this. So the interval would be from -4, there's no equal to, so it's a parenthesis, on out to infinity. Okay, and then number 5, so this time I want this 1 over x graph. Remember, that's the one with the 2 pieces. So 4 units to the right, 3 units up. And remember the 1 over x graph, that's the one where we draw in our new xy axis. So that point that we moved is like our new origin. And then remember the 1 over x graph has the 2 pieces. So it would be this piece and it would be this piece. Something like this. Okay, and then on the other side is a 4. So we draw a horizontal line at 4. So a horizontal line at 4, something like that. And this time it's a less than, so we want all of the blue graph that's below the red graph. Well, I see 2 pieces that are below. All of this piece is below, right? All of this one is below. But also from here on out is below. And so again, because there are 2 pieces, I have to write 2 intervals. Well, the first interval is, it just keeps going this direction, so that's from negative infinity. And keep in mind, intervals are x numbers. So even though this graph is going down, we don't want negative infinity because it's going down to negative infinity. We want to know what's the x value. Well, it's going to get really, really close to x equals 4 without touching it. So I'm going to put a 4 with a parenthesis because that means it gets really, really close to 4 without touching it. And then the second piece picks up over here at x equals 5, right here, picks up at x equals 5, and it goes on out to infinity. Okay, so I have 2 intervals on that one. So if you have 2 pieces, you're going to have 2 intervals. All right, so the homework for 6.5 is the next 2 pages, and basically it's doing exactly what we did. Graph the left side, graph the right side, and then decide if you want the part that's above or below.